Hello everyone. Welcome to GirlScript Goa Regional Summit 2020. Today is the second day and here we are back with another session from your track 1, Data and Business Analytics. As mentioned earlier and as you all know, GirlScript Goa is a part of GirlScript Foundation and aims at spreading technology awareness and knowledge among as many people as possible. As the name suggests, we try to provide some kind of special efforts to let technical education go to women and other underrepresented groups, but we are open to all. Today, we have all of you all here for the regional summit. And just before we start the session, I just want to ask you guys and to tell you guys that if you all were not able to successfully register and that if you all haven't got the mails for the classroom link or the WhatsApp group, please mail us at girlscriptgoa@gmail.com. I'll mention the email in the chat box in a while. About today's session. By analyzing business, the organization and it enhances technical and tactical skills. Business analysts help in decision making and they're definitely needed to make the decision quicker and easier. Today we have with us Mr. Ashish Kohli, who is a senior business analyst at Amazon. He is skilled in Tableau, Python, R, Hive, MS Excel, and so many more. Please join me in welcoming Mr. Ashish Kohli. Over to you, sir.
Thanks a lot for the introduction. Hi guys, good evening. Thanks a lot for joining. Thanks a lot for making time for this. I hope you're all safe and sound. Let me quickly share my screen and we can start. Okay, so hi all. I am Ashish Kohli. So here's the list of things that I want to discuss with you today. After giving a quick introduction about myself, although that's already been done, we'll discuss what very briefly about what is business analytics, and then what is the role of data visualization in business analytics. We'll also explore some commonly used and related terms like business intelligence and uncover what are business intelligence tools. And after that, we'll jump on to defining a problem, looking at a sample data set, and then using the BI tool that we have picked for the day, which is Tableau, to build a data visualization on top of the problem statement. We'll try to untangle the problem, attempt to understand a bit more about the problem using data visualization only. After which I'll open for questions. So I'll just skip the part because my introduction has already been done. When we talk about analytics or business analytics or data science and decision science, there are many terms that are floating around in the industry, and people often confuse it with often actually relate it with just a smaller set of technologies. When we think of business analytics, Python comes to our mind, SQL comes to our mind, Tableau, Power BI comes to our mind, right? But it's not just about technology. So decision science or business analytics is a blanket term, which is a harmony of maths, business, and technology. And each of these play an equally important role in forming up what we know as business analytics. It's not just the technology. A business analyst should be equally skilled in his maths. He should know how to crunch the numbers, how to massage the data in the right format to churn out what's required for the business. And consequently, he should also be very closely connected to the business, because that's the end customer, because that is the businesses for which a business analyst is going to design solutions. On the right side, if you see, I've listed on a few examples of a few functional areas of businesses where analytics play a role. Right? So over the years, the role of analytics has very quickly grown from being a sole enabler for the support functions like customer support teams to being a very crucial component of the core businesses or the core functions of each business. Right nowadays, analytics is used in everything that a business needs to take a decision, be it inventory planning, be it pricing, marketing, optimizing supply chain, optimizing inventory, optimizing human resources, um, making the lives of your employee better, making the experiences of the customers better, and everything. So this is where these are all the different use cases of analytics, right? So when we say it enables better decision making, what do we mean by that? We are just trying to say that analytics helps uncover the indicators from the data that businesses generate, and these indicators help the business leaders take some action on it and derive some key component of their business. Right now, this comes in especially handy when we are on the receiving end of it, we as a customer. That is why you would be seeing many offers that are from the e-commerce apps that are installed on our cell phones, and those offers are very targeted to our own browsing history on those apps, right? They know what are our likes and dislikes. Even on social media platforms like Instagram, Facebook, we see the content which is tailored to our likes and dislikes. We see the content which is very much relevant to us, and even the experience of interacting with customer support services, and getting timely reminder notifications from the companies about the services that we are using. All of these are examples of the customer facing actions that businesses take on by using data analytics, right? Okay, but enough about business analytics, right? Let's talk about data visualization. How does it how does it play a part in this whole picture, right, in this whole scenario? So let's look at this slide. uh, there are two images, one on the left side, one on the right side. The left side depicts a table, the right side depicts a dashboard, right? Now both of these are the exact same data set. They're conveying the same amount of information, they're conveying the exact same piece of information, right? But would you prefer looking at the left side or the right side image? I would personally prefer to look at the dashboard on the right. Why? Because instead of looking at the raw numbers, although that has its own perks, uh, I would much prefer. I would much rather look at a dashboard, right, which at a quick glimpse will help me take some decisions, will help me understand, okay, what's going on, and where do I need to look at. So it's very aptly mentioned that data visualization democratizes analytics, right? What do you mean by that? It brings the benefits of analytics to everyone in the business without them having to deal with maths and technology, right? Now that's the power of data visualization. uh, it enables easier and quicker generation of insights, easier consumption of data, and also it reduces the time to decision making. A stakeholder can very quickly look at this dashboard and tell, okay, where is he performing? Where is his business performing well? Where is it not performing well? What are the focus areas that he should look into? What are the areas that he should invest into? So all these are, some very good decisions that he can take by just looking at this dashboard. So yeah, that's the power of data visualization, right? Um, but when we talk about dashboards and data visualization, right, we try to think about, or we relate it to businesses, right? We relate it to sales performance dashboards, we relate it to customer acquisition, customer churn dashboards, and all the fancy terms that are used in the industry, right? But if we look at objectively, right, we are actually surrounded by data visualization and analytics. There are at least 2 3 different type of dashboards that we see almost on a day-to-day basis without even realizing it's actually a formal dashboard, right? And we look at it and we take some decisions, right? So here are some of the examples. The dashboard on your car, or on your motor vehicle, right? The lock screen of your cell phone, or even the art gallery or a museum are very good examples of data visualization around us. If we look at the lock screen of a cell phone and take instantaneous decisions, do we want to charge my cell phone or do I not? I can look at the upcoming calendar events, I can look at my notifications and whatnot, right? So it is a very good example of a dashboard that surrounds us, that we use in a day-to-day basis. It does not necessarily have to be related to business, right? Okay. Now, what's next is we also, you guys have heard a common term called business intelligence. Business intelligence, which is very closely related to data visualization. Um, Now, what actually is business intelligence? It is a blanket term. Now, it actually combines some aspects of business analytics, some aspects of data visualization, data mining, maintaining infrastructure, and everything, right, into one common umbrella term. Uh, what does it mean for a stakeholder? It helps them understand what is happening in their business, right? And then what are the series of past events that led to the current state where they're in, right? Now, these two very important data points help them plan for the future without even having to rely on, a fancy machine learning model and everything. Businesses more often, rely on their own sense of judgment, which is based off of the indicators that business intelligence gives. So again, so business intelligence is an umbrella term which combines some parts of business analytics and data visualization. Okay. Now below you can see some logos of pretty big names in the visualization industry. All these are known as BI tools, right? Now, very broadly put, we can classify BI tools into two main categories, right? There are a set of tools which allow us to visualize our data, and that's it. They are built only for visualization purposes. That's why they're also known as visualization tools. But then there are full stack BI tools like Looker, like Tableau, which not only help you just visualize your data, but also help you create data pipelines, query your data, build forecasting, machine learning models, and whatnot, right, in one single tool. Okay. Now, so as I mentioned earlier, right, I wanted to give a very quick introduction about business analytics, business intelligence, data visualization, and then jump on to defining a problem, right? So what we will do now is, so this is the what you can see on the screen is it's a sample problem that we will be attempting to solve today, right? We will build a dashboard considering we are in the scenario. So let's look at what's the scenario. You're an analyst for Brooklyn City Council and asked to deep dive the causes of various accidents happening in the borough and come back with pointed insights. Okay. Um, uh, just a quick call out. Borough is like a small part, a smaller town in a larger city. Now, the city of New York has 5 different boroughs, and Brooklyn is one of them. Okay. So we we are an analyst in the Brooklyn City Council, and we are given the task to understand the causes and what are the factors of the large number of accidents that are happening in the city. So this is a data that is published by the government of the city of New York, and if you can see in the table, these are all the different features that are available in the data. So we have by the way, each row in the data set represents one single accident that happened in the city of New York across 5 different boroughs, right? But we'll be focusing our analysis only for Brooklyn. And I have shared this link in the chat window, so you guys can open this and download the data set. What we have in this data set is, the date and time of the crash, the name of the borough where the accident happened, the zip code, some geographical information like latitude and longitude, the street names, how many people were injured or killed, what were the contributing factors, and what were the type of vehicles involved. So it's a very comprehensive data set, and opens up a possibility of many different kinds of deep dives that we can do in the data to understand the whole situation better, right? Okay, now if we click on this link, we'll be taken to this page, right? This is NYC Open Data website, where we can click on export and download the CSV file. Okay, Now, enough of talking. I'll jump to Tableau and we'll start looking at this data set. Okay. Now, if you guys can see my screen, what I'm sharing is the home screen of the Tableau public. And by the way, there are many different variants available of Tableau, like Tableau Desktop, Tableau Server, and this one is a free to use, open to the entire community, called Tableau Public. Right? If you can just Google Tableau Public, you'll get a first link. You can download the software. It's free of cost. It does not require any license, but it has some very limited capabilities in terms of what all we can do with the data, right? Um, okay, now what do we want to do here is we first open the data. Now, since it's a CSV file, we'll select the option called text file and select our data set, which I had already downloaded. And now this is the main screen of Tableau, right? Let's look at what all things are available here. Now, this is the data source page where we can load multiple data sources. Now, multiple data sources can span across, connecting to an RDBMS server, opening a flat file like we did now, directly querying or using data from a web scraper and all. So all this is possible in Tableau, but of course, Tableau Public comes with a limited set of options, and that's why we have it. We are using just a flat file today, right? Okay, now if we click on update now, you'll see it actually fetches a snippet of the entire data set, specifically first 1,000 rows, and shows it to us, right? Now, you can see there are many nulls, and the primary reason for this is because all these accidents are logged or recorded by the parole officers that are there on the streets at the time of the accident, right? Now, of course, there is very little time to log everything, and then before the authorities have to take some action on it. So of course there are many cases where the data is not fully populated, but for this for the purpose of today's session, we'll be only dealing with non-null data set, right? Okay, now you'll see a small call out on the bottom part of the screen. It's called go to worksheet, and on clicking here we'll be taken to the main work area. Now it will take some time to load the entire data set, since what we were seeing now is just a snippet of the data. Okay, let's familiarize ourselves with this layout before we actually jump into doing anything. Okay, now everything that you see here is the work area. All this white space is the work area where we can build visuals, where we can build tables, we can drag and drop data elements, right? Those of you who are familiar with Microsoft Excel, it is very similar to Microsoft Excel. It follows the same structure. We can have multiple sheets. One file is known as one workbook, similar to Microsoft Excel. We can drag and drop data features into the work area here to build whatever we want, similar to the the Power Pivot or just the pivot table features of Microsoft Excel, right? Okay. Now the columns and rows above indicate for a specific visual what should be on our X and Y axis, right? We'll get into more details as when we go there. On this side, we have the marks pane, right? Where we can filter the data set using any of the data features available. We can apply formatting to the visual, like we can change the color, size, text, or add tooltips to it and all. Okay, and then on the left side, we'll see all the columns of our data set being populated here. Okay, now what Tableau does by default is it groups our entire available columns into two parts, right? One is called dimensions, one is called measures. Now, what's the meaning of each? A measure is by as the word suggests, it's something that we can measure. It's something that we can aggregate, right? All the numerical columns are by default considered as measures. So, for example, number of people injured or killed are several measures, right? And dimensions are different columns using which we can slice and dice our measures. So we can see number of people injured across different boroughs, across different streets, across different vehicle types and whatnot, right? Uh, and you'll also see along with all the columns, there is an extra column called count. So that's the file name, and in the bracket it's given count. Now that is an automatic measure created by Tableau for every file that we load. It is basically a count of all the rows that are available in our data set. Okay. Okay. So let's jump into looking at how Tableau works. Right. It's fairly simple. We load the data set. We click on update. We can come to the screen where we are presented to the sheet. Right. Now we just look at the data set that we want to visualize. So for example, let's look at count. So since I mentioned each record in this data set represents one accident that happened, so what I'll do is I'll click it, I'll drop it on the rows feed. Okay, now what it does is it will give me total count or total number of records, okay, which is about 1.7 million, as you can see. Now we want to look at this same piece of data across different visuals. So let's drag the borough field, put it to our columns, right? Okay, now it's as simple as that. Let me quickly widen it. Yeah, so you'll see all the 5 boroughs of New York along with some null values that are being populated, and the counts are populated against each, right? Okay, now this is the primary technique of building any visual in Tableau. All we need to do is drag a feature into columns, drag a feature into rows, and it will build a visual for us, right? And then it's up to us to customize it the way we want. Okay, now let's get into the second part, which is customization of the visuals to convey the message that we want to convey to the audience, right? So, okay, for that, what do we need to do? The first thing is we'll see there's a null column here, right? And I don't want to show nulls to the audience and to my readers. So what I'll do is I need to filter the data set by boroughs, right? So I'll hold the command window, it is for Mac, or the control button for Windows users. And while holding the button, I'll drag it and drop it on filters. Now I'm presented with the screen where I get a list of all the different values in that column, right? I'll simply uncheck null, click OK, and that's all. Okay, very simple. So there are many other ways of doing it. I'll undo. Undo is basically Control Z or Command Z. I can also click on this value, click on exclude. That is also one way of filtering in Tableau. Okay. Right. Now, what do I need to do next is, yeah. Okay. So we have this basic filter at our disposal. Now, I want to look at how many accidents happened across each, right? Now, although hovering over will give me what is the value, what is the specific value. So in Brooklyn, we can see there are about 370,000 accidents that happened in the entire, that are logged in the entire data set, right? But let's say we want to show the values about each bar. Again, we'll do something similar. I'll hold the command button, drag it and drop it on labels, and that's all. Tableau will automatically show all the labels on top of each bar. Okay. Now we can see the same number. Instead of waiting to hover over the icon, we can clearly see that okay, there are 370,000 accidents happening in Brooklyn. But okay, now again, this raw number is not very useful, right? It's not very easily comparable. How far ahead is Brooklyn from, let's say, Manhattan? How would I know that? So let's change these numbers to percentage numbers, right? Okay, how do I do that? We'll click on this little drop down icon here. We'll go to quick table calculation, and we'll click on percentage of total. Okay, now if you can see on hovering over, we can see the percentage value for each. So for Brooklyn it's 31.23, for Manhattan it is 23.56. Okay, but the numbers are still showing as the raw numbers. That's because we already placed the original count on the labels. Now how do we remove it? We'll simply drag it and drop it on the empty space here, and we repeat that process for the percentage numbers. Okay, so you can see Tableau is fairly simple. We can do many things just by dragging and dropping. There's very little to no coding involved in this, and we don't need to, bang our head against a wall in case something goes wrong. Tableau is pretty much convenient in that case. Okay, now let's also add some other touches to this chart. So for example, let's give it a more meaningful name. So accidents across boroughs. Let's right click on this and click on hide. We don't want to show that. And let's give a more meaningful axis name. So I'll right click on edit axis, and we'll change the axis label here. So I'll say percentage of contribution to total accidents. Sounds good. Okay, now we have that label here. We have all the different borough names here, and this chart is done, nice and clean, right? Okay, but now what we are showing here is, okay, how many accidents happened in this, right? But what's also another key indicator of the severity of the situation, how many people were killed in those accidents, right? So instead of just looking at the total count of accidents, let's look at the number of killed. So for that, we'll add a new sheet. Okay, but before that, let me very quickly cover the concept of sheets and dashboards in Tableau. So in Tableau, each sheet will hold only one visual, right? It is for the purpose of one specific analysis, and then what you see on the screen is one single analysis. Okay. To add another visual, we'll click on a new sheet, which is the first icon here. Clicking here will be presented with a new sheet. Okay. Another shortcut is Command T, which will add a new sheet in case of Mac, or Control M in case of Windows, which you guys can do. Okay, let's delete it. We don't need it now. Okay, now we are on a new sheet, and what we want to see is number of persons killed, right? So let's drag it, drop it on rows, drag boroughs, drag it on columns. Okay, let's very quickly repeat the same process. Filters, I'll uncheck nulls. Okay, I'll increase the width a little bit. Now let's add a percentage total, and let's also add the labels. Okay, now let's look at some. Okay, before that, we'll also change the sheet name, which is deaths across boroughs. Okay, so what we have seen is so far, even in terms of accidents, even in terms of deaths, Brooklyn is the highest. So there were maximum number of accidents recorded, maximum number of deaths recorded in Brooklyn. Okay. Now what do we do? Let's now, since the problem statement that we are focused on is only for the Brooklyn City Council, right? So what in that case, we want our readers to focus only on the Brooklyn numbers, and rest everything should be only as a reference point, right? So let's look at how can we bring the attention of the readers here, right? So first of all, let's give some colors to these different boroughs. So again, how to do that? I'll hold down my command button, drag and drop this to the colors feed, and that's all. Tableau will automatically assign a different color to each and every one. Okay. Now we'll click here. We'll click on edit colors, and this is where we can edit all the colors. So since Brooklyn is our focus of attention, let's assign Brooklyn a blue color, and let's change everything back to gray. And there we are. Click on OK. Okay. Now, just with this one simple trick, right? What we've changed is the message that we want to convey to the audience through this visual, right? We want our readers to focus only on Brooklyn. That's why we have highlighted only Brooklyn in this chart, and rest everything is just as a benchmark. So as compared to Manhattan, which contributes to 18% of the total accidents, Brooklyn contributes to 33% of the total accidents, right? Which means the situation in Brooklyn is far more worse. Okay. Now, so we have conveyed two messages so far: number of accidents and number of deaths. Let's also look at another key aspect, right, which is fatality rate. Now, for every accident that happened, how many people were killed? So instead of just reporting the total number of deaths, let's look at a fatality rate. Okay, now this means now that rate is not available as a ready measure in our data set, right? Which means we need to create a measure of our own. And again, Tableau allows us to do that in a very easy way. So what do we need to do? Just right click on any empty space here, click on calculated field, and we are presented with a calculation window. Okay. Now we'll put a very simple formula. Let's give a name, fatality rate. Okay. And sum of number of persons killed. So you type something, Tableau will give suggestions. You can highlight the row and either click it or just press tab on that, and it'll automatically fill it for you. So okay, sum of number of persons killed divided by count or count distinct, it wouldn't matter because every row is already a distinct. So let's look at something that we can count, right? So we have a dimension called collision ID, right, which is again a unique indicator for every single row in the data set. So let's add collision ID. Okay, now what we are doing here is for every single accident, how many people were killed, instead of reporting the total number of people killed. Okay, let's click on OK, and then there you go. We have this new measure called fatality rate. Okay, let's add a new sheet, build a very similar visual, burrows. Let's exclude nulls, and let's drag burrows to the color column. And since we already did that in the previous sheet, Tableau recognized it and filled the same color scheme for us. Okay, and we also let's show the fatality rate as labels. Okay, now what you see, the picture is completely changed now. Instead of earlier, what we were showing was Brooklyn's recording the highest number of deaths across all the boroughs. We see the fatality rate in the Brooklyn is only third highest, right? It's much more worse in Queens and Staten Island. Okay, now what are possible reasons to explain this? It is possible that the population of Brooklyn itself is quite high among all the boroughs, or naturally the number of deaths that are caused by accidents are also high. But when we look at the number of deaths per accident that are happening in each borough, we see the true picture of what's happening, right? So Brooklyn, in Brooklyn, the situation is not so much worse as the initial two charts indicated. Okay, now this brings me to a very important point that I wanted to discuss, which is choosing the right set of visuals and measures, or the data set for your chart is very important, right? And it actually lays the foundation of the message that you want to convey to the audience. We don't want to mislead audience into thinking something is happening where it's not happening at all, right? uh, okay, so let's very quickly give a name to this, which is fatality rate across boroughs. And this, okay. Just excuse me for a minute. Okay. So okay, now what we have done so far is we have done three different analysis. We have looked at accidents, we have looked at deaths, we have looked at fatality rate. Okay, let's look at some other ways we can explore this data. We can slice and dice this data. So we'll click on a new sheet, and let's look at the data set that we have in front of us, right? So we have crash date, crash time, and number of accidents. So let's look at across years how many accidents have happened, right? So how do we do that? We'll drag and drop crash date to columns. Now what you see here is Tableau automatically recognized that this is a date field, and it grouped it into different date features. So this is year. On clicking on plus, we'll see quarters, we'll see months and days, right? So we can drill it down to all these different levels, but let's keep it to year to avoid the clutter. Okay, now let's look at number of accidents across years. Okay, now we are seeing something interesting. We are seeing that uh, it started on an increasing trend. It went to a particular high in 2018, but then it followed a decreasing trend in 2019. And 2020, it is decreasing. We are already in the 9th month, so which means the Brooklyn City Council is doing something good, which is actually reducing or contributing to the reduction in the overall accidents across years, right? Uh, okay, let's look at, but wait, we cannot solely attribute this to Brooklyn City Council. Why? Because this is entire New York's data. So let's put it to colors. Okay, now again we'll very quickly hold down control, go to filters, exclude nulls. Right, now we are seeing slightly different trends here. Uh, so Brooklyn, of course, is highest among all the boroughs, but in 2017 to 2016. Okay, now if we see in Queens, the reduction across the years is not so much as a reduction in Brooklyn, right? Or let's say Bronx, where it is gradually increasing over the years, and only in 2018 to 2019 is when we saw some reduction, right? So it is almost flat across the years, which means even if the government of Bronx is putting in some efforts to reduce the accidents, they are not very effective. Whereas if we compare that to some other boroughs like Brooklyn, we see like a sharp decrease from 2015 to 16 to 17. Okay. Um, let's also look at fatality rate. Now what I'll do here is I'll drag it and drop it to size. Okay. Now if you see, the thickness of the lines has changed according to the fatality rate across years in each and every borough. If we look at Staten Island, the fatality rate was quite high, but it reduced, right? And then this is how it keeps on changing across the years. On Brooklyn, we see the line is thicker towards the front end, but it gradually is of decreasing thickness as we move across the years. but the trend again changes in 2019 and 2020. So, which means that there was some effort that the government is putting to reduce both the fatality rate and the number of accidents across the years. And again, all of these different data points lead us to the same type of insight, right? Um, okay, let's do the same thing. Let's format the chart. So this is total accidents across years, and let's hide this. Double click. Okay, let us also add this to the label. So we can see, okay, what is the fatality rate at each and every data point. It, it is making it everything too cluttered. Let's exclude it. Okay. Now, if we see here, there's a tooltip, right? When we hover over any data point, this tooltip appears and gives us what are the specific data points for that. Okay, but there's a menu here, tooltip menu. Here is we can edit what is the message that we are showing. Okay, let's say I want to show the borough name. Okay, the year is very obvious, so I don't want to show it in a tooltip. Instead of count of crash data.csv, let's give it a more meaningful name. Number of accidents. Okay, and then in the gray areas where you can see the actual measures that are embedded, measures or dimensions that are put here. This is where how the Tableau is getting the information for each and every tooltip. And the third thing is fatality rate. Okay, let's click on OK. Now we see boroughs, number of accidents, and fatality rate. Okay, this is much useful. Let us format it again slightly. So let's say in borough and borough name, yeah. There's so many accidents happened. Leading to a fatality of okay. Yes. Okay, click on OK. Now we see, okay, the tooltip is much more meaningful, much more readable now. In Borough, Brooklyn, 50,847 accidents happened, leading to fatality rate of so and so, right? Now this is how we can edit the tooltips in Tableau as well. We can also give a different color. Let's say I want to color Borough in a different color. I want to put it green. And let's say fatality rate, I want to show it in red, some dark red color. Okay, and there you go. In Brooklyn, so many accidents happened, leading to fatality rate of, and the formatting is preserved across every single data point that we see on the chart, right? Okay. So quick recap, whatever we've seen so far. Number one, how to build a chart. We simply drag and drop fields across the rows and columns field. How to filter chart based on a particular value, right? We also saw how to change the counts to percentage or apply any other measure that is there. We saw how to give conditional formatting, how to highlight one particular data element in a chart. We saw how to create a calculated field, right? And if you also guys noticed, when I drag and dropped different elements in the previous sheets, Tableau automatically built a bar chart for me, whereas in this case it built a line chart for me. Why? Because Tableau is intelligent enough to recognize that line chart is the best suited way to show spatial data or time series data, right? So we are showing data across different years. So line chart is more suitable to show that. But let's say we want to select a different visual, right? How do we do that? Um, let's add a new sheet. And okay, across different boroughs. Let's look at some other field, vehicle type code, right? Which is what is the type of the vehicle that was involved in an accident, right? And let's look at total number of accidents. Okay, so it's a bar chart, which is not very useful. Why? Because there are many. So this data requires cleaning. There's a lot of garbage values here. Let's pick something which is more easily readable. Okay. Now, if you see, there's a show me button here, right? Now, if I click here, it will allow me to select different filters. Now, I don't want to look at this. Let's say I want to look at um, pie chart, right? So since the color is automatically selected, uh, some invisible lines here that I need to drag. Yeah, okay. But if I remove this, yeah. So these are the default set of colors. So we see we can plot a pie chart. Um, we can also drag this, hold command button, drag this sorry, across labels, and we can drag this across labels to get the counts. Okay, so yeah, we can clearly see, okay, among the total accidents happened, how many happened in Brooklyn, Manhattan, Queens, Staten Island, and Bronx, right? But there's something wrong in this visual, right? And something wrong in the way I put it actually. uh, so I mentioned that among the total accidents happened, how many happened in Brooklyn? But since we already know that a very large number of accidents are being logged as null, right? So this is not this pie chart is not adding up to 100%. Now, which means that pie chart is probably not the best visualization to choose, right? This leads me back to the same point that I made earlier, right? We should not plot any misleading information. We should not show any misleading information to our viewers or our audience, right? So we should be very careful about that. So instead of pie chart, let's say I want to look at um, bubble chart. Okay. Now, what this shows is we are not in any way saying that, okay, this entire information adds up to 100%, but it's only the sole purpose of this is to make a relative comparison, right? Relative comparison of different boroughs in terms of the number of accidents happened. Now, if I remove this count field and instead add fatality rate to size, we'll see the same information that we were conveying here in this chart with this bubble chart. Okay, uh, we can clearly, with the help of bubbles, the size of the bubble would indicate what is the fatality rate in that. Okay. Um, let's look at some other type of information, right? We also have latitude and longitude, and we have zip codes, right? So let's plot a map. So I'll click on zip code, put it to columns. I will select number of accidents happened, right? Now it plots a default um, bar chart for me. I'll exclude nulls and I'll select a map. Okay. Now what Tableau has done automatically is it understood where specifically on earth are the zip codes from, and then highlighted those areas for us already, right? uh, Let us select the pan option. So yeah, if we scroll, we can like zoom in or zoom out, and we can see in the entire map of US, the New York City has been highlighted and all the different boroughs have been highlighted, right? But again, we were focused only for Brooklyn. So let's add a filter for boroughs, right? And select Brooklyn only. Click OK. Okay. Now what we have here is just the map of Brooklyn and all the zip codes in Brooklyn, where and the color indicates the number of accidents that are happening in each and every zip code. Okay. Now we also have latitude and longitudes, which indicate the specific intersections in Brooklyn City where those accidents happened. Right. Let's try that. I'll add a new sheet. Okay. So since it's a numerical field, what Tableau has done is it automatically added it to the measures, right? What we'll do is right click on convert to dimension, and we'll do the same thing for longitude, and it will automatically understand these are geographical informations, right? Or there is another way, even if Tableau doesn't automatically recognize it, we'll right click, we'll click on geographic role and select what exactly does this column represent. Now it's a latitude, so latitude has already been selected. Okay, cool. Let's add latitude and longitude and click on the first map icon. Okay. Now, what Tableau has done is it has plotted points for the areas where these latitude and longitude intersect, and we can see there is some erroneous data which we will exclude. Okay, even in this case, just a few more left. There you go. Even these are not needed. Okay, cool. Now, what these points indicate? They indicate the intersection points uh, within the city, within New York City, right? Again, right now it's not at all readable. So what we'll do is we'll clean it up a little bit. We'll first apply a filter for boroughs. Select only Brooklyn. Okay. You can see even there are many wrong points for Brooklyn. Uh, Next we'll do is we'll click on, let's see, we want to change the size of the dots to represent the number of accidents that happened. So we'll drag it and drop it to the size field. Okay, if the chart is taking shape. And let's also change the color of the dots to represent the fatality rate. Okay, let's edit colors. change it to a red color because it indicates accidents. Now, what do you want to do here is uh, there are many outliers in this fatality rate, right? There are many points in this latitude where no accidents happened at all, where only few people were injured, where there was no fatality, which means it's zero. And then you can see the most of the chart has been turned to white because that lies on the left side of the spectrum. Then there are very few dots where there was fatality rate. So even if like one accident happened, that person died, and that is indicated by this bright red dots, this very small bright red dots, right? But okay, to make it more readable, what we'll do is we'll hold down command again, drag it and drop it to the filters field. Just click OK, and we'll click on show filter. Okay, now you can see there's a slider for this. So we'll exclude all the lower fatality rates to see only the relevant points. Okay, we can see, so these are the points within Brooklyn where the fatality rate is above 30% till 100%. Okay, uh, and each of these indicate how many accidents happened. So these are mostly ones. Okay, now you can see there are some big dots but are very light red colored, whereas there are small dots which are very bright red color. Now both these, now a combination of these, which is fatality rate and total accident count, helps us very clearly look at what are some very accident prone sites but are not very dangerous, for example this, and then what are some accident prone sites which are very fatal, so for example this, or all these bright red dots. So okay, this is a very useful chart that will help Brooklyn City Council to take targeted actions instead of taking efforts to reduce uh, uh, accidents throughout the city. They can prioritize these more fatal areas first. Okay, so let's give it a name. Fatal intersections. Okay, and let's also give this a name. Uh, let's also add labels to it. Yeah, so this will give us the total count of accidents happened in each and every zip code. Okay, now what we've done is we have like created a fair amount of sheets. We have added all different sort of filters, um, and created different type of visuals. Uh, but okay, before that, let's also create one more field so that we can um, move on to the next step, which is building a dashboard out of all these different visuals. Okay, so you see there are different fields, which is number of cyclists injured, cyclist killed, number of motorists injured, motorist killed, pedestrians injured, pedestrians killed, right? So which means there are total three type of people involved in every single accident. They're either a cyclist, they're either a motorist, or a pedestrian. Okay, uh, but we don't have any field which is readily available for us to indicate what type of person was involved in an accident, right? So let's create a field using these injured and killed fields. Let's create a new measure, which is something I want to show you guys how to do that. So again, let's right click on empty space, click on calculated field. We'll say type person injured. Now, again, I promise there's very little coding involved, so this is just the basics. I'm not going into too deep. I'm not going into too deep about how to create complex calculated fields and all. This is very simple, but also showcases what's the power of the visualization tool, that is Tableau, right? So we'll say if okay, before I start type out the formula, I'll clearly lay out the logic. We'll see if the number of cyclists injured are greater than zero, then the type of person injured is cyclist. If the number of motorists injured is greater than zero, then the type of person injured is a motorist. And finally, if the type of person injured is type of pedestrian injured is greater than zero, then the person injured was pedestrian. Okay, so I'll say if number of cyclists injured greater than zero, then cyclist. Else, if number of motorists injured greater than zero, then motorist. Else, let's add else if number of pedestrians injured greater than zero, then pedestrian. And let's also add an else condition to the scenarios where it does not match at all. So for example, the null records will say unknown. We can then filter these records out and end. Okay. We'll end the statement with end. Now, after you type out the formula, you give it a few seconds and Tableau will say the calculation is valid. Right? Now I'll just quickly copy it. Okay. So we have this new field called type of persons injured, and let's very quickly create a new field called type of persons killed. Okay. Number of cyclists killed, number of motorists killed, number of pedestrians killed. Good. Okay. Okay, now we have these two fields which were not available in the data, but we have created using one way or the other. And let's look at some trends across these fields, right? So I'll say type of person injured and number of persons injured. Let's filter out unknown. Okay. And let's also build a similar chart. By the way, let's delete it. What we can do is right click, duplicate. So we want to build a similar chart, we can click on right click and duplicate. But anyways, we're going to change both these fields, so it won't really matter. So instead of injured, we'll say killed. And again, instead of this measure, we'll say number of persons killed. Let's yeah. Yeah, okay. Let's again give some meaningful names to this. Okay. Now what we see here is that motorists are the ones that are injured across all the accidents, whereas pedestrians are the ones that are killed across all the accidents. Which also makes sense that motorists have the protection of their bike or their car. Even the most basic automobiles nowadays come with some protection features, right? Whereas pedestrians who are actually walking along the road, they don't have any sort of protection, and whenever they're involved in an accident, highly likely that they get killed. Okay. Let's again do something similar. We want to draw the attention of our readers to this, which means we'll highlight just the pedestrian again with the red color indicating it died, and put everything else as gray. Okay, and similarly for injured, let's give this a color, edit colors. Now for motorist, let's just give like a orange color, not a red color. Okay, okay. So we have a lot of data now at our disposal, right? Now what do we want to do next is we want to put all of this in a single page, right? In a single page in a logical manner, so someone can take a decision out of it, right? Now this is also called as building a story, not specifically for Tableau, but in general BI terms, we say this is how we build a story. We have all the different elements of a story laid out together. All we need to do is just connect them in a logical sequence now. Okay. Now, what we do is instead of clicking at this new sheet button, we'll click on a new dashboard button. Okay. Uh, Now the difference between a dashboard and a sheet is that in dashboard we cannot create any new visual. It is just a collection of all the different sheets that are available. Okay, so let's go to dashboard, and first thing we want to do is change the size. Now by default Tableau selects this size. I don't know why this is a very weird size which is not standard to any device, uh, but let's click on range, go to automatic, and this enables automatic scaling of the dashboard as and when required, right, as the need arises. Okay, so now we have a dashboard, and what do we want to do? We want to lay out all the elements on our dashboard, right? Simplest way is just double clicking everything that we want. Double click, double click, double click, double click. Okay, now Tableau has automatically arranged everything for us, but this looks like a mess, a complete mess. I wouldn't want to look at it any day, right? Now, what do we do in this case? We need to very carefully plan out how we want to show our visuals in this case, right? So, okay, before that, there's an important concept of containers in a dashboard. So we cannot simply put any chart, right, and drag it across, right? You see every chart occupies the entire area. The moment I add a new sheet to this, it can only be added to a specific part of the screen, right? You can see I can only add left half, top half, bottom half, or right half. Okay, now which means that this needs to be planned out very well. Okay, uh, so I'll jump back to my presentation very quick. And we have something called as different layouts, right? So we have a horizontal containers, we have a vertical container available in Tableau. What does horizontal container do? We add a horizontal container, and inside a horizontal container we can lay out things from left to right in a horizontal fashion, right? If we add a vertical container to a sheet, it will only allow us to add things from top to bottom in a vertical fashion. Okay, very simple. You can see if we want to lay out something like this, just for the top bar itself. I hope you guys can see it clearly. Just for the top bar itself, what do we need to do? We need to add a horizontal container. Okay. Similarly, in the layout below, for this right side, we need a vertical container. For this entire thing, we need a horizontal container, and for the top half, we also need a horizontal container, right? So let's look at how this plays out in action. So I have this empty sheet. Uh, what do I want to do? I want to sorry. So I'm having a little bit trouble. Yeah, okay. So first we'll add a vertical container to this. Why? Because there will be different elements that will lay out from top to bottom. Okay. Now inside a vertical container, we want something in the top half. So we'll add a new vertical container in the top half, and we have a vertical container here. Okay. Uh, Now in the top half, we'll add a horizontal container, which means things can be only laid out in a horizontal fashion here. Okay. So I'll say accidents across boroughs and fatality rate across boroughs. So there you go. You have these two things. Okay. Let's very quickly go back to that sheet and change the coloring scheme to what we did earlier. So for Brooklyn blue, for everything gray. Okay. Now we see back to the dashboard. Yeah. Let's hide it for now. And in the bottom half, what do we need now? Let's add total accidents across years. Okay. Now you see it has automatically arranged everything in a logical fashion, right? So what do we see here? So Brooklyn logs the highest number of accidents across all boroughs, whereas in terms of fatality rate, it's only third highest. Okay. Across the years, we can see how the Brooklyn City Council has worked towards improving or reducing the accident rates, improving the road conditions or whatever, however you want to put it, as compared to other boroughs where not much significant progress has been seen. Right. So okay, now just with the help of these three visuals, I just set out a story. We laid out a story. Why? Because all these things are laid out in a logical fashion. Okay. Now we also want to show how does this pan out across different zip codes. And okay, now everything is here. Let's also add a horizontal container at the bottom. Right, reduce the size of it, and inside this horizontal container, let's add type of persons injured, killed, and that's all. That's all, right? Okay. Now this still looks a bit ugly, but let's fix it, right? So first thing is, let's remove all the extra things that we don't need, right? So we don't need this legend of fatality rate. We don't need this legend. We would need this slider to change how our graph looks, or also to enable audience to interact with this dashboard, right? So let's leave it here. We don't need to highlight this specifically in a legend, so let's remove this as well. Okay. Now you see there are some things which are very specific to a particular visual. So for example, this fatality rate is only specific to this highly fatal intersections chart, right? What do we do in that case? We'll click here, click on we'll click on that little drop down icon, select floating here. Okay, and then we'll drag it and put it in this container. Right. Now that's all. So with floating, what we can clearly call out is that the color of dots indicate fatality rate, with the shade of red indicating the higher fatality rate. brighter shade of red indicating higher fatality rate, right? And the size of dots indicate the number of accidents that are happening in that balloon. Okay. Similarly, for these two charts, all we are highlighting is just the highest indicator. We don't need a legend to explicitly call it out. So let's remove that as well. Okay, and there you go. We have this. We can add more filters to it, but now this is a dashboard layout, right? This is a dashboard layout that conveys a clear message to our audience. Okay, uh, and this is how we build a story in Tableau. Okay, now some finishing touches to it. Let's give this dashboard a title. So, what's happening in Brooklyn? Okay. Um, let us add a title to this chart, and let's just add a container on top, reduce the size, and add a text field to it, and say um, motor vehicle in okay, let's increase the size, make it bold. Okay, now again there is still, let's remove this empty container, so this takes the entire space. Okay, we still need to increase the font size a bit and also reduce the font size of these headers, right? Uh, let's add fatality rate back to here. Why? Because on publishing this will mess up our order. Okay. We'll go to let's go to edit title, decrease the so these are some of the final finishing touches that we sorry need to make to our dashboard to just make it look a little bit more clean and readable. Okay, and let's finally increase the size just a little bit. Right. Okay. So okay, now this is our dashboard. Now what's next is we want to save it, right? Now there's a small catch in Tableau Public, right, where we cannot save a dashboard locally. We cannot save a dashboard to our own laptop or desktop. We only need to publish it to the official Tableau Public repository, right? The moment you click save, right, it will ask you to sign in, and on signing in, it will publish it to your own local folder, right? Um, Now, if you are doing this, what happens is, just give me a minute. Right. So on saving this, we can see we are given this link, right? Now this is the link which is our own repository of all the Tableau dashboards that we have built so far, right? Um, so there you go. It's a nice and clean layout. This is a dashboard that I built. This is another dashboard that I built on the same data set, right? Where we can see all the tooltips, all the sliders for interacting that we saw earlier, right? And if we want to add any extra details to it, we can see everything here, right? And since it is public, we are actually contributing to an online community, and everyone can see what what is our dashboard, who has built it, and then what is the meaning or message that it conveys, right? Okay, so now this is what I wanted to cover. I'll move back to the presentation for a bit. And okay, now before moving further, I wanted to showcase some of the examples of bad visualizations or things that you should not do, or things you should keep in mind while building a dashboard. And but before that, so I mentioned earlier that Tableau Public is a community-driven software, and if you open Tableau Public, just sign in with your own email address, you can see all the visualizations that people have built. You can get inspiration from some of the top voted visualizations, and you can learn a lot from all those resources, right? Okay, now, so yeah, so this is something that there are also 5 rules of dashboard building. um, these are like very commonly known terms. So what basically tells us we need to take care of 5 different things, which is understanding the context, choosing an effective visual, eliminating the clutter, focusing attention, and telling a story, right? uh, and if you guys notice, we took care of almost all these things while building the dashboard that we built today. uh, we wanted to understand the context, so we understood the problem. What is it? We tried to focus only on showing Brooklyn's data, how we can slice and dice data to generate more meaningful insights. So context is basically sticking to the problem that you're trying to solve, right? Next is choosing an effective visual. So I give you an example, so multiple examples of uh, what kind of visual is best suited for this kind of data. What are things you should keep in mind to make sure you're not giving out any misleading visual, right? Next is eliminating clutter. This especially comes in handy when you are building out your final dashboard. You're laying out all the different sheets to your dashboard. So you want to make sure there is no clutter in your dashboard. Uh, it's easily readable. It's easy on the eyes, right? Next is focus attention, which is very important, right? So among all the boroughs, so example, so among all the boroughs, we only highlighted Brooklyn because we wanted to focus or grab the attention of our readers to that specific part and use the rest of the bars only as benchmarks or only for comparisons, right? And then finally, tell a story. So tell a story is basically connecting everything. Once we have all the pieces of information that we need, we just connect it in a logical sequence to make sure it flows out well to our readers. Okay, now I also wanted to showcase this. So these are some examples of bad visualizations. Now, why bad? Because they are misleading or misleading the audience by showing this kind of data set, right? So if you can see in this first picture, they say 5.2% of children suffer from spinal injuries, right? Now this is a very scary statistic for any parent out there, right? 5.2% of all children suffer from spinal statistic. The only thing is, the person who built this visualization, they took a wrong denominator, right? They took a denominator of all children who suffered from some kind of injury, and among them it was 5.2%, which means this is actually misleading the audience, right? Same thing happened here in the other chart. So, for example, if we look at this part, they are a news channel is reporting nothing personal against Fox, but what they are doing is they have shown like presidential candidates for 2012, and they have shown a pie chart which doesn't add up to 100%. Right now, although their intention was just to compare, how different candidates are performing. So candidate A is running. So candidate A is leading by 70%. The first runner-up is by 63%. The last one is 60%, right? But choosing pie chart is not the best decision to show this kind of data, right? And also this little chart on top, I don't know if you can see it clearly, but it shows a line which is rising exponentially, right? Now it is basically average monthly temperature logged in 2010 or 11, I guess. Okay, now what's wrong in this picture? It is showing that, okay, global warming is getting out of hand, the temperature is rising significantly. But if you see on the bottom axis, it is only showing the data for the first half of the year. And what we see, this rise in temperature is just a seasonal shift, because a rise in change in temperature because of the seasonal shift. This would have been fair comparison if we see this data across years, across several months, and not just on the period of 6 months, right? So all these things are something that you should keep in mind while planning out what is best visual to choose from, right? Okay, I guess we have few more minutes left into the session. So these are some of the very useful resources, some of the blogs that you can follow. They frequently publish articles on how to do about anything on Tableau, on Power BI, on Microsoft Excel. And there are also some very beautiful visualizations that you can look at, you can take reference from, you can take inspiration from. And also there are some links for not to do's, right? So there are some very commonly made mistakes by users which you should try to avoid. Now I'll open up for questions if you guys have any.
Sir?
Yeah.
Could you repeat the step from where you came to the dimensions part? From the previous step to the dimensions part on Tableau?
Okay, so so you're saying, so when we first load the data, we're presented with this screen, right? Data source.
Yeah.
And there's an indicator. Let me actually open up a new dashboard and show you how that looks. So we'll select a text file, load that same data again. Okay, now you see it says go to worksheet, right? So this is the first sheet that Tableau automatically adds for us. All we need to do is click here. It will take some time to load the data. Yeah, okay. Now here is where we have all the dimensions and measures, right? On the left pane, under the data tab. And all we need to do is just drag anything here, drag anything to the columns field, drag anything to the rows field, and we have a visual. And from show me, we can change the type of visual that we want to see, or whatever. Does it answer? I hope I was able to answer your question.
Chroma, are you?
Yeah, I got it, but I understood all of this, but I was talking about the dimensions part, like when you were making the tables for vertical, like the vertical and horizontal tables. So how did you reach to that point? I got all of this, but like post this, how do you make the vertical and the
Oh,
horizontal?
the dashboard is what you're mentioning.
Sorry. I'm so sorry that I've
Okay.
kept saying dimensions. Yeah.
Okay. So let's quickly add a new dashboard here. Yeah. So let's change the size, automatic. Okay. Now we have all the sheets on the left part, right? All we need to do is just lay them out on the screen here, right? Now there are two containers that you see on the bottom. That is, one is horizontal, one is vertical,
Yeah.
right? Now this will help you plan the layout. So horizontal basically means, let's say you add a horizontal to the screen, you
Hmm.
can only add visuals, right? You can only add subsequent visuals to the right side,
Right.
right? Horizontally. Okay. Let's say you want to add vertically, so we can add a vertical here, right? Now this vertical basically means that I can only add elements to it vertically from top to down. So this,
Got it. Yeah.
right? So this is how we plan our dashboard.
Yeah, got it. Thank you.
Yeah. Any other questions?
Guys, if you have any other questions, feel free to ask. Ashish, there's a question in the chat section. It says,
Okay.
being a mechanical engineer, how was your journey into data science and analysis?
Okay. So when we see look at what is the requirement for a data analyst, or let's say a decision scientist, right? uh, it is not only tech, right? I mentioned time and again that it's not only tech that we need to rely on, right? So there's an aspect of uh, you being able to think inquisitively to understand the data better, right? Now this is something that a mechanical engineering student, or any engineering student for that matter, knows very well, right? Having studied all the subjects like M1, M2, M3, numerical methods, and even working on group projects, solving many different problems during the course of our college years, is what trains you very well for that aspect, that very single aspect. I was lucky enough to be part of a placement drive for a company called Musigma, which is where I was before joining Amazon. Uh, Now, Musigma has a very well-defined, I would say, a very inspiring way of hiring candidates, right? So, what they try to look for is, through a different series of very creative tests, what they try to look for is how well is the candidate in solving different problems. By that, so they'll have like a video synthesis round wherein they'll simply play a video and ask us to, okay, tell what are our key takeaways from that. So what they try to judge is how well we are able to process that information, divide it into logical chunks, and then lay it out very clearly to the person in front of us, right? So that's how Musigma analyzes your skills, and then they do not only focus on what all languages do you understand and what all things do you understand. What they try to understand is how quickly are you able to unlearn something and learn something new, right? Which is very important, in fact, for any field out there, not just data analytics. Um, Now, thanks to Musicma, I got entry into the field of decision science, data science. Um, and and the first few months of my Musicma journey went into me trying to get my hands at all these different tools and technologies, understanding all those programming languages. By the way, I wasn't much I didn't know like too much programming before joining Musicma per se. In my college years, the only programming I knew was how to program a CNC machine to perform a job, or churn out some piece of metal. So that was the only programming that I knew. But even if we look at it objectively, right? So learning programming is does not mean cramming up syntaxes, cramming up all the different libraries that are out there. It simply means that how well you're able to understand what is the problem at hand, break it down into smaller and logical chunks, and then attempt at addressing each of those chunks with whatever you know, right? So that is programming. That's the crux of programming. So that is your problem solving aptitude, which I learned thanks to again the very environment in which I was put in at Musicma. Uh, and yeah, that's how my journey at Musicma began. That's how my journey into the world of data science began. Slowly, I started to learn more on my own. On weekends, I would participate on competitions on Kaggle. Uh, I would read blogs like Analytics with towards data science and whatnot. Right, I would try to implement what all things that have been discussed in a blog or in an article on my own, and then showcase it to my friends and family. Say, hey, look what I did, and so these are like small steps that I took to eventually grow and learn all these different things. um, but again, at the very core, the biggest skill that I've learned that has helped me grow in this field is uh, you know having that inquisitive mindset, understanding how to attempt at a problem, right? Understanding how to break down a problem into logical chunks. That is at the crux of everything, and I feel that's the most important skill that one can learn.
Thank you so much, Ashish. It's pretty motivating, and many of us here who are beginners in coding or who feel that they aren't made for it, I'm sure it's motivated them that there is a future, and if they're given and that they work properly towards it, then they'll definitely get what they can and they want to.
Yeah, definitely. I mean, feel free to reach out to me via any media. I can share my contact information, email address. You also have my LinkedIn profile. But what I usually try to suggest other people, whoever reach out to me, is don't solely focus on coding. So you can eventually learn coding, and any company that you join, they'll give you some time to ramp up. They'll give you some time to understand what is your job role, understand what is it that's required of you. But what's really is judged for candidates in an interview is your problem solving skills, and anyone can build it. You don't have to rely on programming languages to build that skill in yourself. So yeah, uh, thanks for having me here. It's an absolute pleasure, and thank you all for taking out time to listen to me.
Thank you so much,
Yeah.
Ashish. It was a pleasure hosting you, and we are really glad that you could make it. Pretty sure all of us, everyone here, have a much better idea about Tableau and data visualization for business. To all of you all present here, those who hadn't successfully registered for the event or who are not yet on the WhatsApp group or Google Classroom, please email us at girlscriptgoa@gmail.com. Your certificates will be provided on the basis of your task completion. I have put the email address and even the data links, whatever Ashish had presented earlier, they have been put in the chat box. You all can copy it right now. Thank you so much for coming here and hope to see you all at the next session. Thank you so much, Ashish. And thank you, everyone, once again.
Thanks, guys. Bye bye.